morning everybody. Myself Dr. Pramod Wadke. I am Professor and Head of Department Mechanical Engineering, GH Rasani College of Engineering, Nagpur. I welcome everyone for this video lecture series of Energy Conversion 2. This Energy Conversion 2 is very important subject for mechanical branch point of view. So, in this subject we will see how energy is converted from one form of energy into another form. For example, we take the example of car, that is internal combustion engine. In case of car, the heat energy first converted into the chemical energy, or vice versa. We say the chemical energy of fuel is converted into heat energy due to combustion of air fuel mixture, and that heat energy is converted into the mechanical energy with the help of mechanical arrangement. Now, in this energy conversion 2 subject, there are 6 important units. First one is positive displacement compressor, that is reciprocating air compressor. Then second unit is a rotary air compressor. Third unit is internal combustion engine. Fourth unit is testing of internal combustion engine. Fifth unit is gas turbine and jet propulsion, and last very important unit is refrigeration and air conditioning systems. So, I will brief you about all the units one by one. First one is positive displacement compressor, that is reciprocating air compressor. In reciprocating air compressor, the compression of air or gas take place due to compression of piston in the cylinder. You see the working principle of reciprocating air compressor. It consists of the closed cylinder with the piston, connecting rod, crank and crankshaft. This is the TDC position, top dead center position, and this is bottom dead center position. This piston move from top to bottom and complete one stroke. When we start the compressor, this piston move initially from this TDC toward BDC, and suction created inside the cylinder at top portion of the piston, and due to that suction means the pressure below atmospheric pressure. So, due to suction, this suction valve open and the atmospheric air or gas at atmospheric condition suck into the cylinders. So, now the position of this piston is at BDC. During next stroke, this piston move from BDC toward upward, to compress the gas or air, and then at the end of compression, this delivery valve open and the compressed air or compressed gas is supplied to the another cylinder, that is called reservoir. So, in this way this reciprocating air compressor work. Now, in this compressor we have to study various different type of compressor, like single stage compressor, two stage compressor, multi stage compressor, then single acting compressor, double acting compressor, then there are PV diagrams, then the various compression like isothermal compression, adiabatic compression, polytropic compression, and so on. In this topic we will see various calculations, mathematical derivations, and so on. And last we see the various application of this reciprocating air compressor, like the spray painting, then ice plant, then refrigerator, and so on. Now, second important unit is rotary compressor. In rotary air compressor, compression of air take place due to rotary action of the blades. The pressure will increase due to rotary action of the blades in the closed chamber. So, at the outlet pressure will increase, and that is depend upon the size of compressor, design of compressor, and type of compressor. Now, in this rotary compressor there are various applications, and different type of rotary air compressor we select according to the requirement of applications. In this rotary air compressor we see the working principle of Roots blower, then working principle of vane blower, screw compressor, and very important rotary air compressor that is used generally in industrial purpose, that is centrifugal compressor and the axial flow compressor. In this topic we also see various mathematical relations and the problems. Then third unit is the internal combustion engine. So, you know that this internal combustion engine is very useful in automobile. So, internal combustion engine is a one type of prime mover, or we say the machine which convert the chemical energy of fuel first into heat energy due to the combustion of air fuel mixture in the cylinder, and then that heat energy is converted into mechanical energy, and the mechanical energy is available in on the crankshaft of the engine cylinder. So, we see the working principle of this internal combustion engine. It consists of the closed cylinder like this with piston, inlet valve, exhaust valve with the connecting rod, crank and crankshaft. This is the top dead center position, this is the bottom dead center position. In case of petrol engine or spark ignition engine, the one cycle is completed in 4 stroke. First stroke is suction stroke. When the piston move from this TDC to BDC, we say suction stroke. Then when piston move from BDC toward TDC, this is compression stroke. When piston move from TDC again to BDC, this is called power stroke, and at the end again piston move from bottom dead center to top dead center, that is the exhaust stroke. Now, we see the simple working principle of this internal combustion engine. Initially, the piston position of piston is at TDC. When we start the engine with the help of kick or with the help of the key, this shaft, this crankshaft rotate initially, which give the moment to the crankshaft and connecting rod, and with the help of this piston start to move from TDC toward BDC, and suction is created, that is vacuum is created inside the engine cylinder, and due to that vacuum, this inlet valve open initially, and the air fuel mixture from the carburetor that come into the cylinder. When this piston is at BDC, there is a air fuel mixture present inside the engine cylinder. Now, in next stroke, that is the compression stroke, piston move from BDC toward TDC, and compression of air fuel mixture take place inside the engine cylinder, that will increase the pressure and temperature both, and at the end of compression stroke there is a spark, and due to that spark the air fuel mixture burn inside the cylinder, and there is a formation of gas with high temperature and pressure, and due to that again this piston move from TDC toward BDC, and that stroke is called power stroke. That is the working stroke of internal combustion engine, and we will get power available on this crankshaft during this stroke, and at the end again this piston move from BDC toward TDC, and the burning gases from present inside the engine cylinder due to combustion, that is removed through these delivery valves to the atmosphere. So, this is the basic working principle of internal combustion engine, and in this internal combustion engine we have to study various air standard cycle, a fuel cycle, then we have to see the working principle of petrol engine, diesel engine, then 2-stroke engine, 4-stroke engine, then the compression ignition engine, spark ignition engine, then what is the carburation, what is the function of carburetor, that we have to see in this topic. Then how the cooling of engine take place, how the lubrication take place inside the engine cylinder, that we have to study in this internal combustion engine topic. Then next topic is testing of internal combustion engine. So, this is very important topic for mechanical branch point of view and related to internal combustion engine. So, in this testing we check the performance of internal combustion engine. So, there are two type of test we conduct. One is commercial test, that is for commercial purpose, and second one is for thermodynamic test. So, in thermodynamic test we see the various thermodynamic properties and parameters of internal combustion engine, like the indicated power, the brake power. So, indicated power is the power developed by engine cylinder, and that is available inside the engine cylinder, and brake power, that is the power available on the crankshaft of the engine cylinder, that is the useful power for IC engine. And the next parameter that we have to study is the efficiency. First one is mechanical efficiency, second one is the volumetric efficiency, then the how we have to prepare air fuel ratio for the internal combustion engine, then we have to see the brake specific fuel consumption, indicated specific fuel consumption, then various efficiency like brake thermal efficiency, indicated thermal efficiency, and at the end we see the heat balance sheet, or we say the energy balance sheet of internal combustion engine, that is very useful and very important related to internal combustion engine. So, in heat balance sheet we check various parameters, like in left hand side of the heat balance sheet we calculate what is the amount of heat generated by engine cylinder, then how that heat or energy developed by engine cylinder is used for various purposes, like what is the useful energy available on the crankshaft, that is the heat equivalent to brake power, that is number one parameter in right hand side of heat balance sheet. Then second parameter is heat equivalent to the loss in cooling, that is second parameter. So, in this case we calculate what amount of heat loss in cooling of engine. Then third parameter is the heat equivalent to exhaust gas. So, you know that the exhaust gas exhausted to the atmosphere that contain energy, and that energy is near about 25% of total energy generated by the engine cylinder. So, that we have to calculate it in third parameter of heat balance sheet. Then fourth parameter is heat equivalent to steam. Some wet particle or some water particle is available in the exhaust of the IC engine. So, that contains some energy. So, that you have to calculate separately in case of heat balance sheet. And last parameter, that is parameter number 5, the unaccounted heat contain heat loss due to radiation, conduction and convection. So, in this way we can prepare the heat balance sheet or energy balance sheet of internal combustion engine. Then fifth topic is the gas turbine. So, gas turbine is also prime mover like the internal combustion engine, but in gas turbine we use gas, maybe air or inert gases like neon, krypton, argon initially, that is input of the gas turbine, and with the help of combustion we convert that gas into the combustion product, and then that high pressure gas is used to generate the mechanical power in gas turbine. So, there are various applications of gas turbine. In gas turbine nowadays this gas turbine is outdated, but there are some important application of this gas turbine, like in aircraft engine, or we say in case of rocket propulsion, or we say ship propulsion. And the main application till date of this gas turbine is it is used as a standby unit in case of power plant engineering, or in case of hydroelectric power plant. So, in gas turbine unit we see various methods which are used to increase the work output and the thermal efficiency of gas turbine power plant. So, in this case we see the methods like intercooling, then the reheating and the regeneration. So, regeneration method is very useful in gas turbine power plant. With the help of this method we can increase the efficiency of about 20%. So, in regeneration methods what we do, the exhaust gas contain large amount of energy or heat. So, we exhausted that energy to the atmosphere, but in this regeneration methods what we do, we give that energy, wasted energy, to the air or gas coming out from to the gas or air before it to the combustion chamber, so that we can reduce the amount of fuel required for combustion process. and in this way we can increase the efficiency, thermal efficiency of gas turbine power plant with the help of regeneration. Now, in this gas turbine we see some mathematical derivations, some problems, TS diagrams, then the PV diagrams and the application related to gas turbine. Now, in addition to the gas turbine, there is a separate topic, that is jet propulsion, and gas turbine use as a prime mover in jet propulsion systems. So, there are various jet propulsion systems like ramjet, turbojet, turboprop, sea propulsions. So, in this case this gas turbine play a very important role to generate mechanical power, and with the help of that mechanical power that system run or work. Now, the last topic is refrigeration and air conditioning. So, this is very important topic for a mechanical point of view, and in this refrigeration system we see how we maintain the temperature as per requirement. So, refrigeration is a process of removing the heat from the substance at controlled conditions. In refrigeration systems we see the air refrigeration, then the vapor refrigerations. So, main application in this refrigeration system is vapor compression refrigeration systems. So, in vapor compression refrigeration systems there are 5 main components. First one is the compressor. So, generally hermetically sealed compressor is used in this VCRS system, then the condenser, then the receiver, the expansion device. So, in this topic we see the working principle of this VCRS systems and how it is work with these main components. Then we see the TS diagram and PV diagram of refrigeration systems, their mathematical calculations and the derivations. Then main parameters is the refrigerant, which play very important role in refrigeration system. So, there are various refrigerants used in this system like R12, R11, R13, then SO2, ammonia, CO2. So, according to application and the property required, we select the refrigerant for the particular refrigeration systems, and there are various applications of this refrigeration system like the ice plant. We use vapor compression refrigeration systems to generate the ice, then the refrigerator, household refrigerator. So, in this case also this VCS system play very important role, then ice plant. So, there are various applications in this case. Then with addition to this refrigeration we have to study air conditioning systems. So, air conditioning system is a branch of engineering science which deal with the study of conditioning of air. So, in this case we see how we produce the comfort condition for human being. So, that process we will see, and there are various factors which affect this comfort conditions like the temperature of air, then humidity of air, then flow of air, then purity of air. So, these are the factors that we have to study in this topic. Then various application of air conditioning, the working principle of air conditioner which is used in winter season, maybe summer season, that we will see in this topic. Now, you know that this all 6 topics are very important for mechanical branch point of view, and after completion of this topic, after studying this topic, the student can be able to apply various concept of reciprocating air compressor. He can be able to apply the knowledge of internal combustion engine. He or she can apply the knowledge of refrigeration and air conditioning systems. He shall able to know the testing of internal combustion engine, and student can shall be able to use various processes of air conditioning systems. So, this is the overall view of the energy consumption subject. Now, I suggest some books for this EC2 subject. Number 1 book is the thermal Thermal Energy by R.K. Rajput. Second book is Thermal Energy by Domkunwan and Arora. Third book is the internal combustion engine by V. Ganeshan. Fourth book is gas turbine by V. Ganeshan, and fifth book is refrigeration and conditioning for C.P. Arora. Thank you.